Push that rock here with some math. Let's solve some simple logarithmic equations. Sickle bears. Okay, we have here a logarithmic equation. You see we have a logarithm with the variable inside, and we want to know the value of that variable. We want to solve for that variable. But we're going to start by isolating the logarithm itself. So let's highlight this logarithm. There's the logarithm. We want to get that by itself. Now notice what's going on with this logarithm. Let's blow it up so y'all can see it better. We have something multiplied by the logarithm and something added to the logarithm, and we want to get the logarithm by itself. So we're going to undo the addition first, then undo the multiplication. To undo addition, what do? That's right, you subtract. So we're going to subtract 78 from both sides. That's going to give me over here, let's see, that's going to be a negative 60. Now we're trying to get this logarithm by itself. So the other thing we have to do is divide by this a negative 10 to undo this multiplication. We're going to divide by negative 10. So we divide by negative 10 on both sides. Okay, and that's going to give us 6. All right. Now, to undo the log, once you get the log isolated, to undo the log, you just have to know the definition of the logarithm. So you've got to get that definition of the logarithm memorized. Let's write it down. The logarithm's definition says if you have log of some positive base b that's not 1 of p equal to x, that is true if and only if this positive number that's not 1 raised to that x over there is equal to the argument of the log, which is called the power of that base. That's the definition of a log, and we're going to use it now. What's our base in this log? Our base is 2. We're going to write 2 as the base. And then the value of the log, what the log is equal to, is the exponent. So notice this log is equal to 6, so 6 is the exponent. And then it has to equal the argument of the log, so we get x. And then what is the 6 power of 2? Can you double 6 times? 2, 4, 8, 16, 32, 64. So 64 is equal to x. And that's how you do that. I-G-G-Y. Let's do one more and then we'll end this short video. Okay, here is another logarithm equation, logarithmic equation. It's an equation that has the unknown sitting inside a logarithm. So here's our logarithm, and the unknown is inside it. So you first try to isolate that logarithm. Now, that means I need to get rid of this 11, then get rid of this negative 10. So again, I need to undo this 11, I need to subtract. That makes that go away, but it leaves me negative 10 times this natural log of x equals 0 minus 11 is negative 11. So notice, just because I subtract this 11, that negative doesn't go away. Students tend to drop that negative there, but it's still here. So to get rid of that negative 10, I'm going to divide both sides by negative 10. That gets rid of this, because the negative 10 goes into negative 10 one time, so I just have one of these natural logs. And a negative divided into a negative gives me a positive, and 11 divided by 10, well, it's 11 tenths or 1.1. Okay? Now, what's the definition of log? Log base b, some positive base b that's not 1, of some power equals some exponent. So b to the exponent equals the argument of the log, which is the power of this positive base. Again, what's our base when it's base e? Your base when it's base e, by natural log, is base e. So natural log means you have log base e. So our base is e. So, all right, e is a base. What the log is equal to is the exponent. So the exponent is this 1.1 over here. And that has to equal the argument of the log, which is x. Now we should know that e to the 1 is 2.7-ish. So e to the 1.1 is just a little bigger than 2.7. And in fact, that's a value that we have in our memory banks. We know that the natural log of 3 is about 1.1. So e to the 1.1 is about 3. So this answer is approximately 3. Math made simple. Simpson Math.